Okay, it's me, and I'm gonna try and walk you through how to make your 3 graphs this week. And if this makes sense, you'll be able to do the same thing for extra credit and turn it at the end of our quarter/semester. So anyway, here is my computer screen, and I'm just looking at the Stillwater High School's website. And if you go to our staff, that bar right there, click on that. The idea here is you do a search for my web page. So if you type in Weaver there and go, you'll see my face there, and we're going to click on that. All right, so try and keep this as tight as I can. Sorry about the movement. Why is the principal's name there? I don't know. Anyway, we want to scroll down. And there's some kind of neat things here on this web page, including we'd set out camera traps a lot of years, and so you can see slideshows of animals photographed at the Environmental Learning Center. But I want to navigate to Browns Creek data. So the assignment for what to do is on Schoology, but the data lives here, and it looks kind of funky. This is just the first page of the data, and you go, well, where is this data you're talking about? And these are just some descriptions. But at the bottom of the page, you can see these tabs. And the deal is, you have your choice. You can either select W3 or W4. This is Browns Creek, the upstream W3 that we collected bugs from, and you saw the videos for. And then right next to it is W4. So what I want to tell you about that, or the reason that's a big deal, is whichever one you don't choose, if you want to do the exact same assignment for extra credit using the other stream area, you could do that. So let me show you how this works. I'm going to click on W3. And these are a list of all the possible bugs that you could potentially catch at a creek. Of course, we didn't. And this number here is how pollution tolerant they are. And you'll recall that like 1, 2, and 3 is darn good, and 8, 9, 10 is bad. This is kind of the functional group. It just talks about, what their job is in the creek. But most importantly is, here are years, and these years go on and on and on and on. And then where there's a number, that's a particular bug that was caught that year. So this is telling me that in 1998, we got 5 of those isopods. So anyway, this graph can be blown up, just to see all the years to the right, you just move the cursor. And so what is worth note is that there's a spring and a fall sampling. And so I want you to put both those columns together. They're right next to each other typically. So this is the fall of, there's a sliding bar here, but like the fall of 1998 and the spring of 1999, you'd combine those two. Or if you want, maybe it makes more sense to you to combine, it really doesn't matter, but we want to combine a spring and a fall next to each other. So you could probably grab the spring and fall of the same year if you wanted. But anyway, so these two columns we'll consider as one, and we'd add these two together. So anyway, that's one column. Well, this is a ginormous data set. So you can move across. So here's my thinking. We have this giant data set collected by students, and as the year implies, all the way back to the 1990s, late 1990s. Well, you don't want to look at all of it. So how could we make some sense out of sampling every few years instead of doing all years? And, and so I'm also cutting your work in half by saying, well, you can do one sample site or the other, the upstream area of bugs over time or the downstream area of bugs over time, which another one you don't choose, that'll be extra credit. So the first graph that they want you to do is just count how many different species are in the spring and fall sampling for that year. So when you combine those, so it really doesn't matter how many we caught, it just matters how many different kinds we caught. So what's the value in that? Well, what would it say about a creek if the number of different kinds of bugs decreased or increased? That might be telling. And this is a way to take a snapshot every 4 years and do that. The second graph, you'll look at the exact same data for the exact same years that you choose. And I'm suggesting maybe every 4 years or 5 years. You want 5 bars total, so you're 5 snapshots on a giant piece of data. And there is a lesson in all this. I mean, sometimes you can't summarize in a giant database, but you can pick and choose from it and try and make some sense out of it over time. And I think that's valid. So that's what we're doing. So the second graph, what you're going to do is exactly the same thing we'll do next week for homework on a shorter scale. Instead of looking at several years, we're just going to look at this year. What's the number between 0 and 10 when we add up the bugs from upstream Browns Creek and downstream Browns Creek for 2020? I have the bugs. I showed you a little video of collecting the bugs. I showed you a video of once they're in the lab. They've all been identified, and so I'm going to send you, actually it's on the Schoology right now, there's a list of the bugs we caught, both upstream and downstream. So your job is to do the same thing that you're doing for graph number 2, and that is if you multiply the pollution tolerance value times the number of bugs and then add that all together to get a huge number and divide it by the number of bugs, you'll have the average pollution tolerance value for all bugs combined. So that's the second graph. And then the third graph this is fairly standard in the industry for biology, is there are 3 groups of bugs out there. In some cases, we catch more than one from that same group, called their orders. So Ephemoptera, Trichoptera, and Plecoptera. That's stoneflies, caddisflies, mayflies. I've mentioned those 3 before. But if you add up what percent each of your 4-year spans or your 5-year spans, imagine a histogram or you could do a line chart, but essentially when you look at those bugs, how many of the total bugs belong to one of those big 3 groups? So let me show you. I kind of hand drew on the board. I looked all over from some examples of my student work last year, some of their graphs they made. I want you to use Google Sheets because I want you to get familiar with it. So don't do what I'm doing. You can just look at what I've done here as a template for what you'll do using the 2 things side by side, the data on the school website and then Sheets, Google Sheets, to build 3 graphs. So here it is. Here might be your first graph. And you can see I've got a decent title. I neglected to put a word on there. I'd probably put down a word like 4-year increments, Browns Creek species diversity. And then I pretended I was at W3, the upstream site, but it would be worth noting that for the reader of your graph. And then over here, the number, how many different species on the side. And then down here are your years. And if you want to connect dots and make a line graph instead of a histogram, that'd be fine. And underneath it, you should tell me, based on this beautiful data set that we have, that's real data collected by students at Stillwater, what do you think? I mean, does it tell you anything? Like, this graph isn't all that it doesn't tell much. I just made this up, of course, but I mean, it'd be neat to see a linear trend like, oh, the species are going up. We must be doing a better job of maintaining or managing Browns Creek watershed if the species count is going up. Or just the opposite if the opposite were true. Second graph is right here. I call it graph 2, but in this case, pollution tolerance indicator, that's that number right next to the species name on the data set. It's also called the family biotic index. So either of those in my little title there at W3 again, in 4-year increments or 5-year increments. We just want you to have 5 data points where you've added the spring and fall. So over on my scale, it's the pollution tolerance indicator, and it goes from 0 to 10. So that makes sense. And then down here are your years and how many, what was the average. And so that involves some math steps. Sorry. Nobody told me there'd be math. And then tell me, what does this signify? So for instance, maybe the bug diversity is going down, but the bug importance is going up. Actually, it would look like it's going down because it's getting closer to 0. 0 is awesome and 10 is crappy. You'd like to see a trend like this. And as I've already let the cat out of the bag for Browns Creek, most years, if you average them, we're in that 3+ as a numerical value for all of Browns Creek, which is awesome. It's a trout stream. And then the third graph, 4-year increments again. And this EPT is an abbreviation for the 3 families that are supposed to be super important. So Ephemeroptera, Plecoptera, Trichoptera, and those are all stated, in the data. So you just count how many of those are included in your data from the years you select. So again, your graph might look something like this. I got EPT, and it's the percent, how many of a total. So we have a percents here, and then your histogram, and then you would write down, hey, this shows blah, blah, blah. And then lastly, the assignment in Schoology asks you to build these 3 graphs and then print a couple of pictures so you know what you're talking about. So the 3, give me a stonefly, mayfly, a caddisfly, a scud, and a riffle beetle. They're actually written out for you, but include those 5 bugs, a picture of those 5 bugs with your 3 graphs. Package it and send it to me. So hopefully that helps. You're kind of using 3 different things at once. The assignment itself is on Schoology. The data is on the front page of my website. And then finally, you can go to Google Sheets to actually construct a graph or these 3 graphs. So hopefully that helps. I'm not giving you any homework for the APES Chapter 8, which is on geology and mining and that kind of stuff. So there's no homework. This is the only homework you got all week. And if it makes sense, there's a duplicate for the homework for next week, just more contemporary. What else? I might as well mention this too. On Schoology, I included a copy of my previous year